All right, so let's go ahead and look at, so we've been factoring quadratics so far, solved by the quadratic formula or solved by factoring. So let's look at something that it looks a little different. It's not a quadratic, but it is still polynomial. So something like this. This is going to be on page 159 of your text. If you don't have your textbook, that's fine. I'll go ahead and write up the problem up here. We'll go through it in detail. So you get something like this, and the directions are to solve by factoring. So we're going to do solve by factoring. So just like we were solving quadratics, it's still the same process. And we want to get everything equal to 0. We want this equation to say something, something, something equals 0. Usually I like this guy because he's already positive. I'm going to move these two over. I'm going to get rid of these two. So I'm going to subtract 4x from this side. Whatever I do to one side, I have to do the other. And I'm also going to subtract 4 from each side. Right? And then from here, this would become x cubed plus x squared minus 4x minus 4 equals 0. So then you're here, you arrive here, and you think about, well, the first step is always, if there's a greatest common factor, I'll go ahead and I'll factor that out if I can. And I look at all these, and I don't see anything that they all have in common except 1. So then the only other method you really have for these is to factor by grouping. So we look at this, and we say, okay, maybe I will try to group these two because I can clearly see that they both have a 4 in common. That looks pretty obvious. I know these guys, these have a couple x's in common. So what we want to do to be safe before we do that is, I always say, I've told you guys many times, is to change all subtraction to addition. Thank you. So we're going to go ahead and do that. So make this plus negative 4 and make this plus negative 4x and make this plus negative 4. So that way, when we go ahead and we group, we don't have to worry about making a mistake with the negatives. Right? We don't have to worry about this negative on the outside affecting the way it looks. It's fine the way it is, because for addition, order doesn't matter. We can add anything we want, any way we want for addition. So let's look at these. So now factor by grouping says, okay, this is factor by grouping. So now we're just going to look at these two by themselves. Let's just look at these two. What would be the greatest common factor of just these two?
X squared.
Very good, x squared. So we're going to write that out here, divide that out, and now what would be the new guy here, the new binomial?
X plus 1.
Would be x plus 1. Raise your hand if you don't see that part. So what you can do if you don't see it immediately is, if I go back in, if I distribute this x squared back in, I should arrive back here. So let's see if that's right. X squared times x is x cubed, and x squared times 1 is x squared. So when I say factor out, let's understand that factor out has the same meaning as to divide out. To divide out. So I can imagine, I look at both of these and I say, okay, do you see that x squared is the greatest common factor? Because this one only has 2 x's, so I can't take any more out of him. So I look at this and I say, okay, that's the greatest common factor. So now I can look at each individual one and think, okay, if I divide this by x squared, what is x cubed divided by x squared? We can do that off to the side. If I say, okay, x cubed over x squared. When you divide by the same base, we simply subtract the exponents. Please make sure your phone is on silent. Thank you, sir. 3 minus 2 is 1, which is just x to the first, which of course is just x. There's nothing wrong with doing math off to the side. Be careful. In fact, I encourage you, be careful. If you have to do math off to the side, that's fine. Absolutely. And then over here, x squared divided by x squared, well, anything divided by itself, except 0, is going to be 1. You see it now? Yeah. You do? Okay. And then now let's look at these two. So this is the idea of factor by grouping, right? Factor by grouping, it's just like it sounds. I group these two. I'm going to look at these two guys by themselves. I'm going to group these two and just look at them by themselves. And we'll see if algebraically something works out here. And they're going to give you problems. I'm going to give you problems in the textbook that are going to work out. So let's see what happens here. So of these two, what is their greatest common factor? 4 or negative 4. You both are correct. Okay. So which one do we do? Well, you might not know at first. So let's say you take out negative 4. Let's see what happens. So we take out negative 4. So plus negative 4. And we are left with, what's negative 4x divided by negative 4? That is x, good. And what is negative 4 divided by negative 4? Positive 1, good. Right. We see this here, correct? So that's if I divide it out by negative 4. Now imagine if you said, well, I wasn't sure what to do. I decided to factor out 4. That's fine, but if you factor out 4, this guy would actually be the exact opposite of this guy. It would actually say negative x plus negative 1. And if that happens, you just have to be acutely aware and realize that I know where I'm going with this. After you do enough of these, you'll say, okay, I know where I'm supposed to be going. Oh, yeah, that's the exact opposite. So I should have factored out negative 4. And then they'll match perfectly. So now we continue this idea of factor by grouping. We continue this idea of, okay, I have this guy. I'm just going to look at this guy. And I'm just going to look at this guy. Now, do each of these have something in common? The x plus 1, yeah. And it doesn't matter how complicated it looks in parentheses. It doesn't matter how complicated it looks. The fact is, they both have that in common. That is the fact. So I am going to divide that out, no matter how complicated it looks. So I divide out x plus 1. And now, what would be left over?
X squared minus 4.
These two guys. The x squared minus, the x squared and the negative 4. That's what's left over. So I'm going to write that. X squared minus 4. For those of you in the back, please let me know if this is too small. Can you see that clearly? You good? On tape? Okay. So let's continue with this problem. So now we're here, and this is still an equation. So let's not be lazy. Let's definitely always write equals 0 the whole way around, the whole way down. So looking at this, the whole advantage of this was that now we went from something that was just a sum of all these different terms, right? Now we have a product, right? That's the whole advantage of factoring, so we call it the product. Okay, so we know the rule that anything times 0 is 0. So I know that if this is 0, it would make it true because 0 times anything is 0, or this could be 0. So this is where we say, okay, x plus 1 could equal 0, or x squared minus 4 could equal 0. They don't have to be 0 at the same time. And that's why we set the whole equation equal to 0, because of that rule of multiplying by 0. So now we have two separate equations that we can solve for independent of one another. This one, I think, is very simple, right? If I now solve for x, what would be the step to solve for x for here? Subtract 1 from each side, good. Minus 1, minus 1. And we have x equals negative 1. Good. That guy's taken care of. Now this guy here, this here is a special case that you guys learned either last year or the year before. Maybe you forgot, maybe you never learned it. It's a special case that you just, honestly, you just have to recognize it. You have to see it.
2.
It's a difference of squares. Very good. Difference of squares. Okay? So a difference of squares. So if I have x squared minus 4, we know that that should factor out to, and I'll go up here so we have room. This guy's here. And I went in and I already circled. As soon as you find one of your solutions, go ahead and circle it. You know, be proud. Okay, I found one. Awesome. Now this guy here, what would this factor out to?
X plus 2 and x minus 2.
Very good. And now notice here we have a similar situation that we have right here. We have another product. Either one of these can be 0. So we can say x plus 2 equals 0 or x minus 2 equals 0. Solving for this one, subtract 2. We subtract 2 from each side. X would equal negative 2. And for this guy here, solving for x, we would simply add 2 to each side. X equals 2. Any questions, please? Any point along this where it maybe starts to get fuzzy? Yes?
Yeah, so you know we have the x squared minus 4, right?
Yes.
What if you had actually added 4 to each side, and then instead of going through that, I understand you can go through that, but it shows it much like clearer. But if you had did x squared equals 4, you would have put plus or minus 2.
Yes. Yes. So that's another way to do it. So let me show you guys. I'm going to hop over real quick to see what Belush's talking about. We have x squared minus 4 equals 0. Now, if you recognize different squares, that's great. But if for some reason you decide to naturally want to go down the path, okay, plus 4, this is fine, and you get x squared equals positive 4, just be very careful that when you take the square root of each side, so you say, okay, the square root of x squared is actually going to be equal to plus or minus the square root of 4. Because you're taking the even root of something. I think we may have touched on this before, talking about the even root versus the odd root. Anytime it's an even root, it's extremely important to do plus or minus. And this is why typically it's better to recognize difference of squares, because I think a lot of students, you'll end up doing this and you'll forget to write the plus or minus. Because there are, in fact, as we could tell when we did this way, there are, in fact, 2 unique solutions, negative 2 and 2, not just 2. So just be careful that if you do this, that's fine, but because you took the even root, it would be plus or minus 2. So I'll write that off here to the side, the reason we're doing this. So this is because we took the even root of 4. That's the key. The fact that it's even. Right? And then, because I want to show you what, maybe if we took the odd root. What if we had something like this? The cube root of 8. What does this look like? Well, actually, let's write it more properly. Let's do this. Let's write just like we have. If I say x cubed equals 8, and I want to solve for x, in a similar fashion, we could say, okay, I'm going to take the cube root of each side. Okay, so I'm going to take the cube root of x cubed, and I'm going to take the cube root of 8. Now, do I put a plus or minus?
No, it's just 2, because it's a proper cube root. 8 goes into cube root.
Yeah, because this is odd, right? Because this is odd. Because what is, for example, so let's complete this. So x would equal to, what is the cube root of 8? I know you just mentioned it. It's 2. And right, that, so 2 times 2 times 2 is 8. In case you're wondering, okay, why is the cube root of 8 2? Because 2 times 2 times 2 is 8. Okay. Now, why is it not plus or minus 2? Well, what is negative 2 times negative 2 times negative 2? Negative 8. That's right. So the issue with that is that it would produce a false solution. Okay. But overall, this is not the typical approach you want to do. That's why I'm focusing on, if you know the special cases, difference of squares, you want to stick to that, because there's a couple other special cases that we might run into that you guys should have also learned. There's difference of squares. What are the other two? Do you guys remember the other two special cases? There's a difference of squares, and then there is a difference of, very good, and also a sum of, very good. So the difference of cubes and sum of cubes. So we'll wrap up with that, just touching on the special cases that we're probably going to see. Most likely, definitely, we already saw difference of squares, but just in case, we have difference of squares, difference of squares, difference of cubes, and sum of two cubes. There really is no sum of squares for real values, so we're not going to consider those for now. So these are the main special cases that we have that we can be looking at once we run into them, because they will be popping up. One last question before the bell rings. How do I check my answers? How do I know I'm right? Just plug it back in. Exactly. Plug in, and you should plug in just -1, and see if that makes this guy true. Then you can test -2, see if that makes this guy true, and then just test 2 on its own. Plug that in for each x and see if it makes that one true. And if it doesn't, hey, you know you made a mistake. That's the great thing about solving these equations, is you can kind of check if you have the time on homework, time on a quiz, time on a test. If you have time to check your work, always do so. Always an advantage.